Welcome back from the ad break, and let's continue with our lesson. So now we are going to be moving on to the next concept in our concept map, and that is from flow diagram to table representation. So we are going to see how a flow diagram would be equivalent to the table representation, because we would be working with the same function and relationship. So let's look at this flow diagram that we have been given here. So we can see there that the rule is to add 5. And when we're looking at our input values, we have been given there a 4, a 10, and a 37. And of course, when we add 5 to 4, we will get the output value of that 9. When we add 5 to 10, we will get the output value of the 15. And when we add 5 to 37, we will get the output value of the 42. But now we need to take this flow diagram that we have already calculated and represent it in a table. Now, as you can see, the input value being 4, the output value is already written as 9. So that has been done already, as well as the input value of 10 has been written, the output value of 15, and the input value of 37 has been written as the output value of 42. What about the other input values? Well, since as well we know that the rule is that 5 is added to a value, particularly an input value in this case, then we know that we can just take our input value, we are going to add 5, and that is going to give us our output value. So let's go ahead and look at our table and see if we can not add that rule or apply that rule to that input value. So we have 1 as the input value, and when we add 5 to 1, what is the answer? Well, the answer is a 6, because 1 plus 5 is 6. What about the next one? We have 2. When we add 5 onto that, yes, the answer is a 7. What about 3? When we add 5 onto that, the answer is an 8. And lastly, we have 5. And when we add 5 onto that, the answer is going to be a 10. So that is us taking this flow diagram and representing it into our table. And since as well a flow diagram has the rule there in the middle, that means we can also fill out any missing output value that is there, or input value actually. Let's move over to our next question. So here again, we've been given that flow diagram that we've already calculated, and we are supposed to fill in the table and provide an equation for the following rule. So as we can see from the flow diagram and in the statement given, the rule is that a number is divided by 3 and then 4 is added. So we are going to do that. So we can see that with an input of 18, we already have the output of 10. So that has been filled out for us as shown in the flow diagram. Then with an input of 33, we already have the output of 15. What about when the input is a 3? Now in the flow diagram, we can see that it was a negative 3 that was represented. But let's work with a positive 3 and see what will the output be. So from this statement, we know that a number, which is the input value, is going to be divided by 3. Now 3 divided by 3 is of course a 1. So we know that 3 divided by 3, that is going to give us a 1. We are going to go further and add that 4. That is going to give us a 5, because we know that a number divided by itself is 1, and when we add 4 to that 1, that is going to give us a 5. And what would the equation look like for this? So we know that the output values are obtained by taking the input values, dividing them by 3, and from that quotient we are adding 4. So that is what the equation would look like. Let's go on to the next one. Now the next one again has 2 parts to that rule. The flow diagram has already been completed, and we can see that with an input value of 15, the output value of 58 has already been filled out in our table. So let's fill out the rest of the table. Now what is happening to our input values? Well, we are multiplying the input value by 4. So that would be 1 multiplied by 4. And of course, then we are going to subtract 2 from that product. So when we subtract 2 from that product, 1 multiplied by 4 is 4. And when we subtract 2, that is going to leave us with an answer of 2. Let's do the same thing for that input of 20. So the input value of 20, we are going to take that 20 and multiply it by 4 and subtract 2. Now 20 multiplied by 4 is going to give us 80, and when we subtract 2 from that 80, that is going to give us an answer of a 78. And how are we going to now provide an equation for this rule? Of course, we know that to get the output value, we are going to take the input value and multiply it by 4, so that is 4x. And from there, we are going to subtract 2, and that is the equation for that flow diagram as well as that table representation. Then let's go on to this one here where we have, again, the flow diagram is given. Then we are supposed to fill in the table. We can see that those input values have already been filled out with their output values. But what about the 5? Well, let's look at what the rule says. The rule says that the input value is multiplied by 5 and then 3 is subtracted. So our input value being 5, we're going to multiply this by 5. And then we are going to subtract 3. So 5 multiplied by 5 is, of course, 25. And when we subtract 3 from that, our answer is going to be a 22. And how would we provide a formula or an algebraic rule for this one here? Well, we know that the output value is found by taking the input value, multiplying it by 5 and subtracting 3 from that answer. So that is how we are going to solve that. Let's end off with the last concept in our concept map, and that is from word representation to formulas or equations and equations. So the first one there says, determine an algebraic rule for the following rule. It says there a number is divided by 3 and then 4 is added to the quotient. So we know that this rule is going to result in the output. So we are going to use y for the output. And then when we say a number is divided, what number are we talking about? Of course, we are talking about the input value. So a number is divided by 3 and then we are adding 4. So this is us moving from word representation to a formula or an algebraic rule. Let's look at the next one. It says there, the volume of a rectangular prism is calculated by multiplying the length, the breadth, and the width together. So again, we are supposed to determine algebraic rule for the statement that has been given to us there. So if we write it down here, we are saying that the volume is equal or is calculated by multiplying the length. So that means we are going to multiply the length with the breadth, and that is going to be multiplied with the width. And of course, for us to write it nicely as a formula or an algebraic rule, we are just going to use our symbol. So for the volume, we can use our V, and for the length, we can use an L. Of course, we are going to multiply that by our breadth, which is our B, and multiply that by our width, which is our W. Of course, we can represent our algebraic rule by saying that V is equals to L times B times W, and that would be our algebraic rule. Let's move on to the next one. Again, we are determining an algebraic rule from the statement because we are moving from word representation to a formula. It says there, a value is multiplied by 4, and then 2 is subtracted from that product. So we are going to take a value. What value are we talking about? Of course, this is the input value because it is the one that goes through our rule, and it will produce an output value. So that value is multiplied by 4. So we know that our input value is going to be multiplied by 4, and then 2 is subtracted from that product. Of course, there is our formula moving from the word representation to the formula. And then our last question there is again us determining an algebraic rule from the statement. It says the speed of a car is determined by dividing the distance covered by the time the car took to cover that distance. So when we look at our statement, it says there that the speed of this car is determined, so meaning the speed is equals to, so it is determined by dividing. So we are going to divide these two. What are we dividing? We are dividing the distance covered by the time that the car took. So we are going to say that is the distance covered divided by the time, and that is how we are going to determine the speed. So using our symbols here, we are just going to say that S to represent speed is equals to D to represent our distance, and this is divided by a time, or T, to represent that time. So that is what our algebraic rule would look like for that statement. That was a wonderful lesson. I really enjoyed it, and I hope you enjoyed it too. We hope to see you next time. Goodbye.